All right. So for the Chapter 9 review material, there's kind of a lot of different topics that are thrown in here. So I tried to structure it the best I could. Let's start off with some basic vocabulary. One thing to start off with is the word solution. What solution means is it's just number or numbers that satisfy an equation. So when you go to plug those numbers into the equation, it makes it true. There's three types of solutions. There's something called a conditional solution. Conditional solution is what you might think of when you're solving an equation. Conditional just means that there's one answer. So for example, if you get like x equals 2 or something, that would be an example of a conditional solution. Something else that could happen is you can get all reals. This is a little more rare. It doesn't happen all the time. But when you go to solve an equation, if you get an answer where it's like 0 is equal to 0, that just means that the equation works all the time. It doesn't matter which number you pick for x, it'll work regardless. And then the last type of solution is called no solution problem. So with a no solution problem, you'd get an answer that just doesn't make sense. Like you might get 2 is equal to 7. Obviously, that doesn't make sense. So no matter what number you pick for x, that equation will never be true. So those are different types of solutions. What I wanted to do next, of course, are show you some examples of all of these. So let's kind of set things up. I'm just going to ask you to solve the following. And we'll start with -3 times 2x plus 1 is equal to 3x. All right. So the way we handle a problem like this is if there's a number outside parentheses, we distribute. What that means is you multiply -3 times everything that's inside parentheses. So -3 times 2 is -6x. -3 times 1 is -3. We have that other word solve. What solve means is that means to isolate the variable. So we just want to get x by itself. So in order to do that, let's get all the variables on the left-hand side of the equation and the numbers on the right-hand side. So we could subtract 3x on both sides. So the variables are on the left. Let's get the numbers on the right. And then we just want to get x by itself. So we're multiplying by -9. The inverse of multiplying is to divide by -9. And then we could just simplify. So x would be -1/3. We would call that a conditional solution. All right, so that's the first type of problem. What if we had something like this now? We'll just keep building on the difficulty level. So what if we had 2 times x minus 2 plus 2 times 3 minus x is equal to 5. So instead of having just one distribution, looks like we have 2. So we'll multiply 2 times everything inside the parentheses, 2 times x, and then 2 times -2, and then 2 times 3, and 2 times -x is -2x. So once we distribute, now we want to combine like terms. 2x minus 2x, well, they just cancel. -4 plus 6 is 2. What kind of solution would this be? There's no solution, right? There's no x, and obviously that doesn't make sense. So you would just tell me that there's no solution. On the test, you wouldn't tell me 2 equals 5 because 2 doesn't equal 5, right? You would tell me that there's no solution. Yes? Yeah, so no solution is also written like this. Very good. Do you know what that's called? Yeah, it's called null. So null means that there's no answer. That's different than 0. If 0 is an answer, that means if you plug in 0, it'll work. This means that no matter what you plug in, it won't work. All right, very good. All right, what if we had something where it's like 2 times 3x minus 5 is equal to 4 times x minus 1 minus 6? Okay, well, just like before, just multiply the numbers outside the parentheses. All right. 2 times 3 is 6x minus 10. 4 times x is 4x minus 4. Combine our like terms. It looks like the left side is fine the way it is. The right side, -4 minus 6 is just -10. And then we want to try to get all the variables on the left side and all the constants on the right. So if we just subtract 4x and add the 10, we get 2x is equal to 0. And we don't want to know what 2x is. We want to know what just x is. So we have to get rid of that 2 in front. And we could divide everything by 2. So x is equal to 0 would be the conditional solution. So 0 is the answer here. That's different than the last problem where there was no solution. So the solution here is 0. One thing I like about math is that we're doing the same thing over and over again with different numbers. So if you just follow the rules, you'll get the right answer. People get hung up because they misapply the rules or they don't know the rules. So let's try another one. What if we had 4 times x plus 3 is equal to 4 times x minus 2 plus 20? Yeah, question. Let's see, the very first one I did. Yeah, so if you get an answer where it's x equals something, that's called a conditional solution. All right, so conditional is like a normal solution. We also had no solution, which means that there is no x left. This third one we did, this is also called a conditional because we got x in our answer, x equals 0. I have a feeling letter D is going to be a funny answer. Let's see what happens here. You're welcome. So we'll go ahead and distribute the 4. We'll have to distribute this 4 as well, just like we've done in other examples. So 4 times x is 4x plus 12, and that's equal to 4x minus 8 plus 20. Just like we did before, let's combine our like terms, and then we'll get all the variables on the left-hand side. And we get 12 is equal to 12. And obviously 12 is equal to 12. So what would we put for the answer for this? Yeah, we're going to put all real numbers or all solutions. I'd actually prefer if you wrote all real numbers. And again, you don't want to just leave it at 12 equals 12, right? I know 12 is 12, right? But the answer would be all real solutions. All right, a couple more of these. One way I can make them a little more challenging is with fractions. So if we had like 1/2 x plus 3 is equal to 1/3. It's not really that big of a deal. I mean, we could subtract the 3 and divide by 1/2, but there is a shortcut in math to just get rid of all the fractions. Does anyone know what that is? How can you get rid of all the fractions in an equation? Yeah. What do you mean by that?
So like 6, for example, the fraction.
Very good. So the answer was, in order to get rid of fractions, we can multiply everything by what's called the least common denominator. The least common denominator is the smallest number that you could divide 2 and 3 both into. So 2 and 3 could both be divided into 6. If we multiply everything by 6, that's a little trick to get rid of all the fractions. It just makes things a little bit easier. So I'm going to write out all the steps. 6 times 1/2 plus 6 times 3 is equal to 6 times 1/3. Hopefully you could do this in your head. If not, there's no shame in using the $10 calculator on Amazon. But 6 times 1/2 is just 3x. 6 times 3 is 18. 6 times 1/3 is 2. So obviously that's an easier equation to work with than the initial one. We subtract 18 on both sides. We get 3x is equal to -16. And then just dividing by the 3 because we want x by itself, we get x is equal to -16/3. From this class forward, if you have to take pre-calc or anything else beyond this, you always want to write the answer as an improper fraction. So 16/3 is the way you want to write the answer. You don't want to use a decimal, and you don't want to use mixed fractions. You don't want to write 5 1/3. That's kind of what we do at maybe high school or elementary school. At this level, we use improper fractions. And then I had one more example like this, where it's x minus 1/2 is equal to 1/3 x plus 1/4. Obviously, this looks a little more complicated, but can anyone think of the smallest number that 2, 3, and 4 could be divided into? 12, right? So very good. If we multiply everything by the LCD of 12, I like drawing these arches or like this rainbow, because a common mistake that people do is they forget one number to multiply by 12 and then it throws everything off. So if we just do 12 times x minus 12 times 1/2 is equal to 12 times 1/3 x plus 12 times 1/4. That'll get rid of all our fractions, and then it'll be a simple equation to finish. So this is just 12x minus 6 is equal to 4x plus 3. And that looks like one of the initial equations that we talked about. You could just subtract 4x on both sides. add 6 on both sides. And x would be 9/8. You don't have to write that it's a conditional equation. The only time you have to write what type of solution it is if it's no solution or all real numbers. Otherwise, you could just tell me what x is. All right. So that's how we solve equations. The next thing we're going to take a look at is how to convert English to expressions or to equations. So let me show you what I'm talking about. Using x as the unknown number, write the statement below as an equation and then solve. So we're converting English to math. And in order to do that, I just want to explain to you a few rules. If you ever see the word sum or more than, this means plus in math, obviously. The word difference or less than, this in math converts to a minus or a subtraction sign. A product is multiplication. And quotient is division. So I had a couple of these. What we'll do is we'll set up expressions with this, and then we'll get to some word problems. So let's convert the sum of 3 times a number and 5 is equal to the sum of a number and 7. All right, so let's try to convert. We know sum means plus. 3 times a number is 3x and 5. So what we just did here is we converted 3 times a number and 5. The sum of 3 times a number of 5 is just 3x plus 5 is how we write that. Is equal to, equal sign, the sum, so we have another plus, a number and 7. Now it's the same thing we did before. And you'll notice that a lot in this class. What we do is, it's not like I'm teaching you anything super new. It's just kind of like a snowball is being rolled down the hill. It just keeps growing, one extra step each time. So for this, we could just subtract x on both sides, subtract the 5 on both sides, and we get, if we divide by 2, x would be 1. All right, try another one. What about 2 times the number minus 3 is equal to 4 times the number plus 5. So just like before, I mean, let's get started. 2 times the number. We don't know what that number is, so we could just use a variable. 2 times the number would be 2x minus 3 is equal to 4 times the number plus 5. And then just like before, we could solve it by bringing the 4x over and adding the 3. Negative 2x is 8. And then we just get x is negative 4. While you're copying that down, just kind of a little fact you might not know. Arithmetic is math with numbers. So like 2 plus 2 is 4. That's arithmetic. Algebra is math with letters. So x plus 2 is 4. That's algebra. My favorite math is the next class from here, which is pre-calc. Trigonometry is within pre-calc, and trigonometry is math with words. So it's like sine, cosine, that kind of stuff. I wanted to show you one more of these before we get to the word problems. What if I said 2 less than a number is 8? You want to take a shot at this? Yeah. What's that? It's a good try. 2x means that there's a product, right? So I don't believe this said times or a product. So you're on the right path, but I was looking for something else. Yeah.
2 minus x equals 8.
It's a good idea, right? Well, there's a difference, right? So 2 less than a number is 8. What's the number? 10, right? 2 less than 10 is 8. So does that mean we do 10 minus 2 is 8? Or is it 2 minus 10 is 8? First one, 10 minus 2. This one's a little tricky. That's why I wanted to show you this. Whenever you have like less than, what that means is you kind of have to switch the order. So 2 less than a number means x minus 2 is 8. And then you could see that's the right way to do it because you get 10, right? Obviously, 2 less than 10 is 8, but you just have to set it up correctly by switching the order. right? So let me show you something a little bit different. I'll call it applications. I'm calling it applications because word problems scare people. Applications is less scary. We're going to be doing the same thing here. We're going to be converting English to math and then solving. So it's going to be a little bit of writing, so just kind of hang with me here while we write this down. First problem says a 26-foot piece of wood is cut into 3 pieces so that the second piece is twice as long as the first, and the third is 2 inches more than 3 times the length of the first. Find the length of the pieces. Okay. I'll give you a minute or so to copy that down so we could all keep up with this. One thing that I would do just to get started is draw just kind of draw a piece of wood that's cut into 3 pieces. And we know the total is 26 feet. Now what we have to do is try to decipher what this problem's telling us. So we know the whole thing is 26 feet. And it says the second piece is twice as long as the third, or twice as long as the first. So do we know how long the first piece is? No. In math, we put an X for something we don't know. The third, all right, let me see here. The second piece is twice as long as the first. So if the first is X, what would the second piece be? 2X. So obviously the second piece is twice as long as the first, and the third is 2 inches more than 3 times the length of the first. So that's kind of like an expression we just did. So 3 times the length of the first plus 2, right? That's what this is telling us. So that third piece is 2 inches more than 3 times the length of the first. So that would be how we have to set it up. We know all 3 pieces of wood add up to 26 feet. So this is a little annoying because if you're going to be adding 2 inches to one and they add up to 26 feet, we want to try to have all the same units. So what we could do to set this up is the first piece plus the second piece plus the third piece equals the total length. We know the first piece is x, the second piece is 2x, the third piece is 3x plus 2, and 26 feet. If we were going to convert that to inches, we should just do 26 times 12 to make sure that we're all using the same units. Now it's easy. The hard part was getting here. And by the way, when you go to do the homework, you'll see that my math lab homework is like the same problem as this, but instead of adding 2, you might have had to add 5 on the homework. When you get to the exam, instead of adding 5, you might have to add 3. All right, so what I'm trying to tell you is as long as you could understand the problems I'm showing you in class, when it comes time for the homework or the exams, there's no surprises. Just the numbers are going to be different. Okay. Let's go ahead and finish this. I'll get out my $10 calculator I got from the Amazon link. Yeah, question. That's a good question. The 26 says it's 26 feet. So if we have an equation, we have to have all the same units. So if this is in feet, all of this has to be in feet too. Does that make sense? But I think the problem says it's 2 more inches. So I know that this is in inches. So what I'm going to do is convert 26 feet to inches by multiplying by 12. Does that make sense? All right, you're welcome. All right, so let's clean this up. We have x plus 2x plus 3x is 6x plus 2 is equal to 26 times 12, which is 312. Subtracting 2. And then dividing by 6. 310 divided by 6 is 51.7 inches. I don't think that's the answer though, because the question's asking us find the length of the pieces, right? So let's answer by saying, all right, what's the first length, what's the second, and then what's the third? X represented that first length, so that would be 51.7 inches. The second piece would be 2 times X, or 2 times 51.7, and that's 103.4. Again, what we're doing is we're just plugging X back in. And the third piece would be 3 times 51.7 plus 2. And that's 157.1 inches. That would be the answer to the question. Okay, a few more of these. Let's take a look at if a car rental company charges $32.50 per day and 25 cents per mile. If Sarah rents a car for 3 days and has a $250 budget, how many miles can she drive? Okay. So let's try to convert English to math now. It looks like we have so much cost. And the cost is going to be $32.50 per day plus 25 cents per mile. I mean, we could always convert this to variables. That's what we do in algebra. Let's put cost, we can make C. Number of days, we don't know how many days. I mean, it says 3 days, but we could always plug that in a second. Plus 0.25 times M for miles. Well, it's $32.50 per day, so I'm going to plug that in for D. Or let me see. Actually, that's fake news here. Sarah rents a car for 3 days, so the number of days is 3. So $32.50 for 3 days. That's where we plug those numbers. $250 budget is how much she could afford to spend, obviously. So that's going to go for the total cost that she could afford. And the only thing we don't know is how many miles she can drive. So once we get everything organized, now we could solve it. I'm going to do $32.50 times 3. And then we want to get M by itself. So just like in other equations, it doesn't have to be on the left side. I mean, it might make our life a little easier to just subtract the 97.50. Then we want to get M by itself, and right now it has 0.25 in front. So if we just divide both sides by 0.25, $152.5 divided by 0.25 is 610. We could also just say, she could drive 610 miles. It doesn't matter if you change the order. A couple more word problems I wanted to go over with you. About 3 consecutive numbers add to 45. What are the numbers? What does consecutive mean? In the sequence, right? So one right after the other. 1, 2, 3, 4, 5, 6. Consecutive even numbers would be like 2, 4, 6, right? But for this, it's just asking us 3 consecutive numbers. So we have the first number plus the second number plus the third number, and that equals 45. Well, we don't know what the first number is. So in math, when we don't know something, we could just write X. What would be an expression for that second number? X plus 1, right? If the first number is 5, the next number would be 6. So you add 1 to the previous number. And what about the third number? X plus 2, right? That would make sense. So now that we set it up, we could solve it. X plus X plus X just gives us 3X plus 3 is 45. Subtracting the 3. So this would be 42. And then if you divide by 3, what'd you guys get? X would be what? 14. Thank you. That's not the answer, right? The answer, it's asking us what are the numbers. So we have a first number, the second number, and then the third number. So 14, 15, 16. If you add those numbers together, you'd get 45. All right, how about in college football? Penn State beat Rutgers by 32 points. I went to Penn State. That's why they won by 32 points. Their combined score was 52. What did each team get? What was the score of each team? Now, we don't want to just start guessing and checking, right? That's not why we use algebra. We use algebra to systematically figure out the answer. Well, theoretically, if we take Penn State's score and we add Rutgers' score, you get 52, right? Anyone want to take a shot at setting this up? We know Penn State was 32 points more than Rutgers. We don't know Rutgers. Yeah.
52 minus 32.
52 minus 32 equals X. You'd get 18, right? So then 18 plus I don't know if that's it. I don't know if that's it. 52 minus 32 is 20, right? So if the one team scored 20, that would mean that the other team scored 52. But that can't be it because together they're supposed to be 52, right? So it's a good idea. All right, but let's wrestle with it a little bit more. Yeah.
32 plus X equals
32 plus X equals 52. So we're going to wind up doing the same thing, right? So we're just kind of throwing 32 around, right? Let's try to come up with some kind of logic for it. We know that Penn State was 32 more than Rutgers. Do we know what Rutgers was? No. What were you going to say?
X plus 32 plus X.
That is the correct answer. So if Penn State is 32 more than Rutgers, I have no idea what Rutgers scored. So we'll just call it X. And we know that Penn State was 32 more than that. Does that make sense? Right. So now that we set it up, X plus X is 2X plus 32. And we could just solve it. It looks like X would just be 10. And remember, X was what Rutgers got, right? So Rutgers got 10 points and Penn State got 10 plus 32, which is 42. Together, that adds up to 52. Wanted to try to finish up with formulas and maybe one more word problem. Okay? So they're all kind of the same thing. So formulas like the formula for the area of a rectangle. Area is length times width. What we're going to practice with this section is just manipulating the formulas. So instead of solving for like X equals 2, we might get X equals Y plus Z or something like that. So it's the same idea. The directions for this section are going to be to substitute the given values into the formula and solve for the unknown variable. We'll start off with the area of a circle. Area is equal to pi r squared. All we're doing for this section is just, if I tell you pi is 3.14 and the radius is 2, all we have to do is just plug those values in for these variables. Simple, 3.14 times 2 to the second. I'm just going to type that into my calculator. 4 times 3.14 is 12.56. Pretty easy. The formula for perimeter is 2 times the length plus 2 times the width. And let's figure out what the perimeter would be if the length is 4 and the perimeter is 18. So it looks like what we don't know is the width here. What we're doing is called evaluating. Evaluating means plugging in numbers for variables. Anytime you plug in a number, you should use parentheses. So if L is 4, I'm just going to write it like that. Perimeter is 18. We don't need parentheses if it's just by itself. So it looks like the only thing we don't know is that width. But we could easily find it. 2 times 4 is 8. Subtract 8 on both sides. And then divide by 2. And we get the width is 5. And now what I'm going to ask you to do is, still working with formulas, let's solve for the specified variable. So if I gave you 2x minus 3y is equal to 6, I'd like us to solve for y. What that means is get rid of everything else except y. We want to get y by itself. Generally, the way that we do these is we kind of work from the outside and work our way in. Another way to think about solving. How many of you have heard of the acronym PEMDAS? Right? Generally, we go this direction when we're simplifying. We go this direction when we're solving. So I'm asking you to solve for y. So the first thing we're going to look to do is add or subtract to get rid of terms. We could just subtract 2x on both sides, and we get negative 3y is equal to 6 minus 2x. And now that we have y by itself, let's just get rid of the negative 3 by dividing everything by negative 3. That would be our final answer. Before we were manipulating numbers, now we're manipulating letters. Yeah.
Not simplify the 6.
That's a good question. So the question is, can you simplify, maybe 3 goes into 6 twice? Is that what you're thinking? So I would say that the answer is no, you can't do that, because if you're dividing everything on top by 3, you have to divide the 2 by 3 also. You can't just divide the 6 by 3. You also have to divide the 2 by 3. Does that make sense? So total, a separate question. This is not related, but say if you had 6 minus 2x divided by 2, you're allowed to say, okay, 2 goes into 6 3 times, 2 goes into 2 once. You see what I did there? I divided everything on top by 2. You can't just divide something by 2 and not everything. Does that make sense? Okay. All right, a couple more things here. What if we had 3xy is equal to z, and I wanted to get the x by itself? Well, right now we're multiplying by 3 and we're multiplying by y, right? So this is simple. You could just divide everything by 3y. And there you go, x is by itself. I like those questions, by the way. If you guys are thinking, well, why don't you simplify this, or why don't you do this? Ask me and I'll tell you if you can. That's how you learn. To finish class up, I have one more word problem for us, okay? And then that'll be it today. When we're talking about area, that's the space inside. And we know that area is equal to length times width. When we talk about perimeter, this just means the sum of the outside lengths. So let's keep that in mind and answer this question. A flower bed is in the shape of a triangle. one side is twice the length of the shortest side, and the third side is 16 feet more than the length of the shortest side. Find the dimensions. If the perimeter is 128 feet. So this is similar to the rectangle that we did a few minutes ago. All right. So let's call this, we'll call this side 1. We'll call this side 2. And we'll call this side 3. Okay. Side 1 will let be the shortest. And we'll just call that X. The other side is twice the length of the shortest side. So if the shortest is X, the other side is 2X, right? The third side is 16 feet more than the length of the shortest side. So 16 feet more than the shortest would just be X plus 16. All we have to do to finish is we're going to take the first plus the second plus the third, and that's going to give us 128 feet. Or X plus 2X plus X plus 16 is 128. Two X plus 2X, we just get 4X plus 16 is 128. Uh, 128 minus 16. And then dividing by 4 is 28. Okay. So we have our sides, the first, second, and third. The shortest side is just 28. Second side is double that, 56. And then the third side is going to be 28 plus 16. It's 44.